Okay, today's topic is the shifting of secant and cosecant type graphs. Alright, so we'll get right through it. Number 41, y is equal to cosecant of x minus pi. These problems today are fairly easy. Tomorrow, when we review for the test and give the test, we're going to have a test on this tomorrow and Friday. So they'll be a little bit more difficult, and I'll go over the review, and we'll do it the exact same way we did the last time. All right, now since this is a cosecant, we're going to treat it as a sine. There's the parent graph for the sine. And this has no amplitude and no period change, just a shift. So that's the only thing we really have to keep track of here. And this will be a radian problem from negative pi to 2 pi. Okay. So the shift is found by setting x minus pi, the argument, equal to 0, so x is equal to pi. This will be shifted pi units to the right. Okay, so the period is 2 pi because it's not being changed. That means the half cycle is pi and the quarter cycle is pi over 2. All right, so if we're going negative pi to 2 pi, that means we're going to need 2 tick marks to the left and 4 to the right. All right, so we will draw, the critical point, remember, of the sine graph is right there. So we're going to move that to the right, put it right there. That's 2 tick marks, pi units, half cycle. Okay, that's the critical point. So what happens at the critical point of the sine graph? It's going up. Okay, quarter cycle, everything has amplitude of 1, so to the left it's down, to the right it's up. These are all quarter cycles. And same thing that we've always been doing with the sinusoids, okay? Okay, we draw with a dashed line. Okay, so anywhere there is a inflection point, there we have an asymptote, and we label our asymptotes. Okay, this one is x is equal to 0. That's x is equal to pi. This is x is equal to 2 pi. That's x is equal to negative pi. When this part is up, the graph goes up, or when it's above the x-axis, I should say. That's down, the graph goes down. Okay, and it's as simple as that. And then we check by grapher. All right, first thing, since we've been working in degrees lately, we'll check, make sure we go to radian mode. And this is, remember, we want, and we can, I mean, we're not multiplying it by anything, but I'm in the habit of putting this into parentheses. I guess it doesn't really make any difference, but this is a reciprocal of the sine, so we have 1 divided by the sine of x minus pi. Okay, in the window, negative pi to 2 pi. Tick marks at pi over 2. Let's go negative 4 to 4. Should be good. And here we go. Perfect. Okay. Not even going to check any points. Just keep this short and sweet for you. Since the year is winding down. And seniors only have a little bit time to go. Of course, I don't think anybody watches my videos anymore. All right. second one is a secant type graph, and remember the parent graph for the secant is cosine, or not the parent graph, but the reciprocal function. So we'll draw a quick cosine, and we have to put points in there. All right, we've got an amplitude change this time. We have no period change, but we do have the shift. Okay, so let's keep track of the shift. So this time x plus pi is equal to 0. So x is shifted negative pi units, pi to the left. And the period, even though it doesn't change, we should write it down. It's 2 pi. So the half cycle is 1 pi, and the quarter cycle, oops, I said quarter cycle. I wrote p over 2 is pi over 2. Okay, and again, this one's going to be a radian problem, obviously, because we've got pi base shift, and we're going to go from negative pi to 2 pi again. Okay, so quarter cycles, everything's quarter cycle for us, remember. Okay, to the left, 4 to the right. Okay, this time, if you look at the cosine graph, the critical point is the high point. That's going to be shifted pi units to the left. So that is going to be, and we're going up to 2. So that point right there should be on the graph, and that will be negative pi 2. Okay, everything else is quarter cycle, remember. Quarter cycle. I don't know if I labeled my points in the last graph. I'll have to go check on that at the end. Okay. Again, asymptotes, wherever there is a inflection point. Oh, I should remember, this isn't the graph, so we don't graph it with a solid line. Okay. All right, so that's negative pi over 2. So we'll label that. That's positive pi over 2. That's 3 pi over 2. All right, anytime we're up here, we go up. Okay, so we should label that point. That's negative pi 2. This point is negative pi over 2, 0. This point is 0, negative 2. This point is pi over 2, 0. Oops. This point is pi 0. This point is 3 pi over 2. That's not pi 0, that is pi 2. Take that back. And this point is, and this one's going down, so it's going to be in the way of my graph. Let me move this. Okay, and that point is 2 pi negative 2. All right, let's check by graph. This time we want 2 divided by, clear that, or pardon me, 2 times, in parentheses, 1 divided by cosine of x plus pi. Now, I've come to the conclusion over the years that it's easiest to just put this part in parentheses and just keep it 1 divided by. And then if you have to multiply it by something else, you multiply it by something else. Okay, our window, I don't believe, has changed. Maybe we should go to negative 5 to 5 here. Okay. All right, are we on screen? Let me move this up just a bit. Okay. Okay. Perfect. You guys should all be good at graphing trigonometric stuff by now, because we have practiced this extensively, I think, and again, we have trace. So, you know, checking values that say pi, and they should match what you already have on your paper. Now, you really should do this on the paper first and then check by grapher. I mean, that's the way to do it. All right, so we have two problems. They are 42 and 44, and they'll both be radian problems, and they will both be from negative pi to 2 pi. Pretty simple. Problems tonight, not so difficult. Okay, tomorrow I'm gonna put the review. I'll do a video on the review problems, and they're a little bit more difficult than the stuff we've been doing the last couple of days. And then I will have the test on there, and the test will be, well, we'll see. I don't know. We want to finish up the test by the end of the week, so I don't know if we'll do it tomorrow or when Thursday. So we'll have to see about that. I'll let you know tomorrow, but the test will be done either probably Thursday. We'll probably have the test Thursday. Okay.